I'm going to show you a way that you could figure it out in a ratio form or whatever. The other way is your purple mold colored sheet there would also help you to answer these questions. Okay? Mole wheel you could use. I find it a little more difficult to use it, but you could. So, what do we know? We know liters, right? Or volume. And what is that? Right, volume. 0.0 what?
1255 liters.
Okay. What else do I know? Polarity or concentrations, or C or M, I guess, whatever way you want to do it. What is the number here? Okay, what are we being asked for? Okay, so you can think about it by using the mole wheel. You probably could use it to put your finger on moles, that's what you're looking for, and you have concentration. They're going to go up. What do you have to do by that volume? Multiply it, and you could answer it that way. You could do it kind of like a ratio or using the formula. So I'm just going to show you the formula way in case that way makes a little more sense to you. So we would look at it 0.500 molarity equals x, x being the moles, right? Because we don't know what the moles are. And if you think about molarity, what's my actual units instead of the capital M? Moles per liter. So x, so what's going to go on the bottom then? My liters. 0.1355 liters. This is another way that you can do it. I'm just showing it to you in case this way makes more sense. Okay? So what am I going to do with those two numbers? Multiply them together. Answer would be, if I did the math right, oh, thank you. Good? Okay. And then now I'm going to jump to 5, we'll do 5, yeah. Alright, 5 says, how many liters of water are needed to make 3.5 milliliter solution that has 40 moles of KOH in it? Okay, again, I would set it up the same way as I just did that last one. Okay, so what do we know? Well, we know M or C, which is your 3.5. What else do I know? What is it? What do I want to find? So I would set it up the same way. Okay, so I would do 3.5 molarity equals my 40.0 moles and divide by the volume. Right? So I'm going to solve for it. And I should get 11.4 liters. So this divided by that. Okay. Again, you could still use the mole wheel and figure it out the same type of way. I find it a little more difficult to use the mole wheel for this question because the volume or liters is on the arrow, right? You see that? You're looking at a mole wheel? So I find it a little more difficult to go that way. This is where that purpley mold sheet that you have has those formulas, and it says concentration equals moles divided by liters. So that's why I'm using this one. Okay? So I'm going to move to 7. And I know I talked about this, I believe, this morning in the review for those of us that were there. You were asked about it. I set it up the same way. So I look at it as 3.0 moles per liter. What am I being asked for again? So mass is my question. So here I'm going to have moles divided by my volume of 0.05 liters. Again, this would be your concentration or molarity. Moles and liters. Multiply those together. Right? So here I would get 0.15 moles. Are we okay with this so far? So once we have our moles, how am I going to get to a mass? Multiply by molar mass. Okay, so again, the mole sheet you could use, or you could use the mole wheel. So how do I find my molar mass? NaCl. Looking at those numbers, 22.99 plus 35.45 equals 58.44 grams per mole. If we forget what the units are, where do I find them? Periodic table. Then what am I going to do? I'm multiplying them together, so my 0.15 moles with my 58.44 grams per mole. And what's my answer? So we'll do 10 first, then we'll move to 11. So 10, talking about parts per million. Parts per million was in that concentration units handout that you had, that you're supposed to read on your own. Okay, go through that information. We didn't do a bunch of practice ones or anything like that, or I didn't do any of them together with you. You're supposed to look through it on your own. So parts per million. Formula is solute divided by solution. When we read the question, it tells us to remember to convert our milligrams to grams. Remember that M stands for what? Milligrams. What does that M in milligrams stand for? I don't know. That times to the negative 3. That was like right. So my 1.5 milligrams converted to grams. Moving it over 3 times. 1, 2, 3. 0.0015 grams. Make sense? Okay. Or instead of moving it over 3 times, what do I divide that? Okay. So once we've done that, we now need to plug our information into our formula. So my solute is what? Okay. And if we think about the definition of solute, what does solute mean again? It's a solid that is being dissolved. Okay. So it makes sense that we're going to use iron. So then a solution, definition-wise, what is a solution? Sorry. Everything mixed together. So my solute and solvent together, right? So what values am I going to have to add together then? So for my people that weren't here this morning, does that make sense? Adding those two together. Wait. One thing that I forgot to put on, I think, on my thing this morning is did I write times 1 million on it? And I did solutes on it. That's where I forgot. It's because it's in the formula sheet. I just forgot to write it this morning in order to get to our answer. So when we multiply this out, so this times our 1 million there, I'm going to get 0.75, and it's going to be ppm, parts per million. Okay. 11. Okay. Alright, so 11 is a little more difficult in the fact that it's getting us to work backwards. So a computer screen cleaner has a liquefied petroleum gas as one of its components. If the concentration is 450 parts per million, what is the mass in grams of a liquefied petroleum gas in a 600 gram bottle of cleaner? So, what do we know? Parts per million and my solution. Why do you say solution? It's a thing altogether, right? Do you see that? So this means that I'm just going to plug it into that formula. So that parts per million equals. So I'm just gonna write it up so that we see it. Solute. Can I write that for solution? Are you okay? Million. Okay, so I'm gonna start plugging them in. What's my value for parts per million? 450. Do I know my solute? Do I know my solution? What is it?
A million times like how much we put together or just the solid.
Hold it. Sorry, what's my value here? 600 grams times this million. Okay? So in my world, how I do this is that I'm going to get rid of this first and then deal with my fractions. Okay? What am I going to do? 450 divided by my million. You good with that? Make sense? Okay? So I'm going to get some ugly number here. Should be 4.5 times 10 to the negative 4. Managed to make a math mistake. So, okay. Okay, so I just put an X there instead of solute. Now what am I going to do? Multiply by 600. Times 600. Times 600. Multiply together. And I should get X equals 0.27, right? And my units are grams. That's my solute.
You get 450 times 600 and divide by a million.
Yeah, it should be the same. We think. I just do it this way because I like to leave my fraction to the end. But it should be the same. I can't see why it would be different. It doesn't make sense that it would be a smaller number. Right? My solute has got to be a smaller number. Why do I say that? Mixing is only part of it, right? So it's got to be a smaller number. So if you ever see a larger number, what are you going to do? Look back to find out where your error is. Okay? Because you're thinking about when you're mixing something together, you're going to have a big solution, a lot of it. And when I mixed it, I only had small pieces of each. Right? Alright. So I'm going to skip a few again. Then I'm going to take you to number, it says 22, but 20 is really what it should be because it's out of order. So, did I, like, make it right where it says solubility curve? Does yours still say 22? Yeah. Okay. We're going to go with 22. So, solubility curve handout to answer the following questions. Again, this is another one we talked about this morning really quickly, but it is one that you were supposed to have read through. So, you're going to have to go back to your 4.2 that has a solubility curve, and we're going to look at it. Now, I asked some questions this morning. This one is asking you to do a little bit of different. So it says, at what temperature will sodium nitrate and potassium nitrate dissolve the same amount of solid? 69 degrees. Do we agree with Courtney? Close enough? Okay. Now, not all of us were here this morning, so how do we explain that to our classmates?
We go to sodium nitrate and potassium nitrate unit, and then we just go down to temperature and volume.
Okay, so where my two lines cross each other means that they both have the same sodium or same mass amount, right? How much is that mass? $135? Still something in there? So do we see how we're going across and we're just making like a straight line with rulers would be the best way or easiest way to do this for yourself. Okay, oftentimes on an exam, if I was to ask you something like this, if you're within 1 to 2 degrees or grams, I'm probably going to accept it, or you'll see it as multiple choice, and you'll have an obvious answer that you need to choose from. We're okay with using that chart? Okay. So, we said 69, 67, I wrote 67. 69 if we had it too would be acceptable, right? So we're now going to look at B. Now, on your chart, there isn't ammonium chloride, I don't think. Okay, so we're just going to generalize this. Explain the energy being used in the process of dissolving ammonium chloride. How do we dissolve something? What things can I do to make it dissolve faster? Heat. Anything else? Stir it.
If you have less grams.
Okay, if we could reduce it or whatever, potentially change our concentration. Usually we want to use the same amount. Okay, so the best one is going to be heat though, right? Easiest one to do, least work for us to do. All you're doing is strengthen it up, right? Whereas stirring, depending on what it is, that's a lot. Make sense? Okay, so if we looked at something else on your chart, not ammonium chloride, someone name it different. Potassium nitrate. As you look at the temperature, okay, as the temperature increases, what do you notice about those values? How many grams is it? It's higher and higher and higher, right? So at a very low number, we see a low amount of grams being dissolved, right?
At 0, it's like 11 grams.
Right, and then what about at 60?
110 grams.
Okay, what about 100? Okay, so we can see from this chart, even though we don't have ammonium chloride, but based on yours, that as we add heat, we're able to dissolve more. Make sense? Okay. So C is asking the same one because I believe I'm missing nitrogen trihydride. So again, it would be the same answer, right? We would be looking at heat. I'm just gonna write not on chart in case we looking at this. So we look at D, it says a potassium nitrate solution is at a temperature of 50 degrees. What mass of solute per 100 grams would have to be saturated? So find me 50 degrees and find me the potassium nitrate. Okay, so let's think about this. So when we're saying at 50 degrees, we have about 85, 88, somewhere in there. Okay, so what number do we want to use, just as a general? 85? Okay, so 85. 85 degrees, or 85 grams per 50 degrees. That's when it would be saturated. Okay, that's 8, or I shouldn't say 8, the first part of D, DI or whatever. Okay, you see that? You looked on the chart, you found it at 50 degrees, 85. Okay? About approximately. Okay, so when we look at these words, I'm just going to ask you something. Saturated. What does saturated mean?
There's a lot of
Okay, what's a, instead of saying something, what's a fancy word that I'm using? Salt. So there's lots of solute that's not dissolved. Okay? Make sense? Lots of solute not dissolved. Would you like sugar water? a bunch of sugar still in there. Right? Saturated. So, the next question, part 2 there, says what mass of solute per 100 grams could it have in it to be unsaturated? So what does unsaturated mean?
It's not totally fluorescent.
Right, I could still dissolve more. Okay, so maximum amount, fancy way of saying it, I could still dissolve more. What's my answer going to be then? Less than 85. Any value below my 85 is going to allow me to dissolve more. If I say 50, it's still going to do 35 more. If I say 30, it's still going to do 55 more, right? So it makes sense to say less? Alright, so then it says for the third one, what mass of solute per 100 grams could it have in to be supersaturated? So what does supersaturated mean? So I'm thinking that's one, you know.
React off to the
Okay. So, enough that swift. What does this mean? Okay, so it's actually gone beyond the amount that it can hold, normally, right? When we talk about supersaturated, how do I get something to be supersaturated? I add a lot of solute, but normally if I add a lot of solute, it just falls to the bottom, right? So when I heat it up, I allow it to dissolve more than it normally can, so therefore it's probably supersaturated, or it has a big amount to the bottom. Does that make sense? So supersaturated has too much solute. Are you with me? So therefore, what's my answer going to be for this one?
Above 85.
Above 85. Does that make sense? So, the only thing that you see though at the draft board is basically to be asked at temperature or grams of what it's going to be, and then you might get asked something to the effect of saturated or unsaturated. Okay? So, there was one that I was thinking of doing, if people want me to look at it, and that's at number 21 about the solubility table, to create the steps for it. As the first thing, and then after that I would just start going in order. Are we okay with that?
Yeah.
Is there anybody who has another particular question that we have not touched on? Number 3? Okay, so I'll hit that one right away. So I'll do the 21 and then 3. Anybody else have another one particularly that they want us to look at?
You just go
Order? Okay. So, let's look at 21. You're going to have to pull out your charts here to help us out. Make this go by faster. So, using the solubility table, indicate how the following ions must be separated using selective precipitation. You can use a flow chart if you choose to, but you must include all your balanced precipitation equations. Some people like flow charts because it makes more sense. So, Lily and I are having a conversation just to give you another example of how this could work. If you have a container and you have rocks and gravel and sand, and I told you that I want you to separate all those items. Darcy, you're wanting to pick each item out separately if I can? Why not? Take too long? Alright, Darcy's lazy. Okay. So, what are we going to do inside, Darcy? What would you want me to do? A strand? Okay, and what is the strand going to do? Leave the rocks behind, so I get all the sand out. Okay, so then I have my gravel and my big rocks. How are you going to separate those? Okay, so bigger holes, and then I can separate them out. Make sense? Okay, so when you're doing this, it's like the same thing. You're trying to take one off, and then take another one off, right? So it's like, I'm trying to get rid of the sand first. So in this case, it might be that I'm trying to get rid of silver first. Okay? So, we're going to look at this. I usually start with whatever that are seen there. What I did was, and I didn't mention this to you previously, was I found that it got a little difficult when we had 4, so I actually crossed out sodium Na1 and BNH4 plus just because we were having trouble. I can't remember if it was I made an error or what it was. So we'll just use 3 for this one. So I usually go in order just so that it's less confusing for myself, and I look to see if I can make a precipitate out of it without causing anything else to come out. So I'm going to look at silver. Okay? So we're going to find silver on our yellow sheet. Find me silver. What's that has found 1 silver.
I found 2, 3.
Okay, so there's lots. Okay. So first silver that I saw Alyssa point to really fast was rule 5. Okay. Rule 5. When it's with silver, acetate, does it make me a precipitate? Yeah. So I can use that. Now I'm gonna ask Courtney, you said you found a second one? Where's your second? Rule 6. Okay, that's with bromine, chlorine, and iodine. Okay. Now rule 6 has more than just silver in its fancy little line there, right? Okay. Are any of those other ones for 21 found there? No. Okay. So does this mean that Alyssa could put acetate down, Courtney could put bromine, Theo could put iodine, and Jeremy could put chlorine? Yeah. Which means any one of those are acceptable, right? So, which one do we want to use? Alright. Ag plus I is going to give me Ag. What am I missing? Alrighty.
And the 8
And balance, which is it was already balanced. Okay. Do we agree with this one now? Okay, so the way that I do this for myself is that I cross out or I check off or whatever sodium or the silver, sorry, so I know I'm done. Does that make sense? Okay, so I'm gonna look at iron next. This is the next one. Find me iron on there.
is for any of them.
Any of them?
Yes, isn't it all others?
Okay, so acetate's gonna make me?
Pardon?
Acetate? No.
No.
The bromine, chlorine, iodine?
10 of those.
No.
Okay.
How do I read straight into that?
Oh, from 7 down to 10? Is that what we're saying?
No,
8.
7,
8 to 10.
8 to 10? So we've narrowed this down 8 to 10. Okay, so now we gotta look at this and decide if, what's our other one? Calcium?
8 doesn't work.
8 doesn't work?
Oh wait, no it does, it does. Because
The
it's
other
the
two
sodium.
don't, the calcium.
So if we're looking at 8, 8 with a sulfide would be soluble for calcium, right? So we could use sulfide. Is that what we're saying? Okay, we could. Yep.
But we use the energy then because they're both non-soluble.
Okay, so 2 ways of approaching this then. First way is that if we saw that sulfide one right away, we do sulfide first. Now some of us skipped it and said that it wasn't there or whatever the case was. So that means, how could I do this differently? Because that's one correct way. It's another way to do it. It started with iron, so I'd have to start with iron. I could do Ca first. Because it precipitates calcium. Is there one that has calcium right away that does not have iron?
Yeah,
Which one?
7.
7? What's that?
Sulfate.
Sulfate. Okay, so I could do it that way. So you see how there's several options here? Which one do we want to do? Sulfate with calcium? Okay. So I forgot to number this to tell myself that'd be the first step. Second step, we're saying calcium plus sulfate to give me calcium sulfate, sorry. What am I missing? Good. Oops. Anything else? We're good? Okay. So then I would cross out calcium because we did that one. Leaving us with iron. So we know automatically it's got to be iron. Now, does it have a particular charge that it gave it to us? +3. Okay. So you said rule 910 had iron? Is that correct? And 8? Okay. So, varies, I guess. Which one are we wanting to look at? 8? Okay. So, I'm going to do 8 for you guys. I'm just going to point this out because I'm lazy. I like laziness. For myself, when I'm doing chemistry, phosphate. What's my charge for phosphate? What's my charge for iron? +3. What's my charge for sulfide? -2, and my iron is this +3. So I'm gonna have to do crisscrossing and all that other jazz, right? If I can find my ions that are matched up in charges, then it's nice and easy and it's just completely balanced. Does that make sense? So I do that for myself because I want the quickest way to give me my answer and one where I'm less likely to make mistakes. Okay, but we'll do your sulfide. So, sulfide, charge is -2. What am I doing here? Here? Like that?
And then here, that's, I guess.
Okay? Because at the end I had to crisscross my charges and then I have to balance everything, right? So, reason why I would have chose the phosphate one is because +3, -3 just be equal across the board. Does that make sense? Okay. So, let's look at B for 21 then. Yep, it just told you to find me a route that's going to have them. Tell me precipitation with the ions. So you did that, you told me the way that it has to go. Make sure you number them, so I know which one goes first. So, start this off. I told you to cross off NH4+, right? For some reason, I think your mercury in your sheet there, does it have a +1 or +2 charge on the yellow sheet? On the yellow sheet. Is it 2? Okay, let's change it to a 2, just for ease. So, on your white sheet, change that to a 2 instead of a +1. Yeah. Because your yellow sheet only has the +2s on there, does that make sense? You're really silent. Okay, so we have Hg +2, lead +2, and magnesium +2. Okay? Same thing. Starting off, we're going to look at Hg first. Finding out with Hg. Okay? Rule 6. Does lead or magnesium come to play? Uh-oh. So I can't do that first. Okay? Rule 7 does the same thing. So this means that I probably can't start with mercury first. So let's look at lead then. Find me lead. 6. We just talked about it. I'm gonna have that. 7, I'm gonna have that too. 8 or 9.
8 because sometimes
Okay. Okay. We do it that way. I went down to 10. You see all the different choices, right? So what are we doing? 8. So my PD is a +2 aqueous, and we're putting it with.
They're both solid.
Are they both solid?
They're
Solid
both
enough?
solid, but it's only magnesium. It's solid.
Only magnesium, so we can't use this rule? Did we miss that?
Because then maybe 2 of them are both solid.
Okay, so we can't use it. Oh, back up. So we can't use that one. So I'm gonna use lead still. What else can I use then? You said so we can't use 8. We're going to 10. All of them are non-soluble in 10. Okay, so then what are we doing?
I'm so confused with the soluble and non-soluble.
So soluble means that it's not gonna make a precipitate. I need to make a precipitate. So we said we can't use 10. Low soluble, but are my other 2 in there? Okay, so then I can't use it. Then it means that we've looked at mercury and lead, so we need to start with something else. So look at magnesium. Is it still the same?
Yeah.
Should I have an error somewhere going on then? I just wrote mine really out fast.
Because M-juicing is soluble, or H-juicing low solubility too. So then therefore you
Okay, so first one's first. Our bromine chloride, we can't do it because we have lead and mercury, right? And then let's go to the next one. Can't use sulfate because we have lead and mercury. Okay. And then let's go to the next one. Sulfide. All of them. This would be a plus 1 charge. Lead and mercury and magnesium. Okay, so we can't make an order without something precipitating out at the same time then. Correct? Okay, so then therefore we won't be able to answer the question because of an error there. So I'll just indicate error on this one. Look at it and find a different one. Okay, so then I heard 3, so I'm going to skip B. Do you have an idea though of how to do that and how you have to keep looking ahead? Okay. So, 3 was the next one I heard, and then I'm going to go in order. Alright, 3. It says calculate the molarity of sodium carbonate with this 4,500 mils containing 7.778 or 7.7. So I have a mass of 7.78 grams. I have a volume, which is, I'm going to convert it right away into 4.5 liters, and I'm being asked for molarity or concentration. Correct? Okay, I would use my flowchart, mole wheel, to help myself out. So using my mole wheel, I'm going to put my finger on concentration, which is on the bottom there, and I'm going to start at mass. So if I'm at mass, what is my first thing I'm going to do?
mass, you're going to divide by molar mass.
Divide by molar mass. How do I get molar mass again?
Your elements.
Add my elements, so I'm just going to give an answer here. Hopefully I didn't make a mistake, so you might want to check it over. 83.
Oh yeah, you did make a mistake on this one.
Did I have a mistake on this one?
Yeah, Miss Gannon said it.
Oh, 105.99?
Yeah.
Oh, she wrote it there.
They just didn't change it.
Okay, there we go. 105.99 grams per mole. Dividing it, right? Depends on how you'd like to see this. So then, this is 0.073 moles. Did I have that part right?
Yep.
Yep. Okay. So now that I found my moles, how am I getting down to my molarity or concentration? Divide by my volume. What's my volume? Good. So I'm just going to write this over here just so I don't confuse anybody or myself. What do I get?
0.06.
Done.
Yeah, I got 8.
Me too. It's because you have to multiply two sodiums.
So if we look at sodium carbonate, CO3, it starches. Therefore, we have to crisscross that and have that too. I made the same error, so this one got circled. Which is good. It's not a mistake that I made. Except for the obviously failure, right? Oh wait. 0.016. I'm just like, no. Alright. Good enough? Alright, so this brings us back to 2 then. Alright, so solid, aqueous, solid is written there, aqueous, do we agree?
Yeah.
Moving on to C, MgSO4, the solid, going to give me Mg plus 2, aqueous, plus an SO4, which is -2, which is aqueous. Moving on to D, G3PO4, solid, would give me 3K plus, or aqueous, plus my phosphate ion, which is aqueous. We're good? Can I just go on to the next page, or is that anybody need to stop it down? Moving on. So we've done 2, we already did 3, we talked 4, right? And 5? So we're on to 6? Alright. When someone else tries to read through this, they might get confused. Determine the concentration of the solution of blah 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 blah. So what are we gonna do? Take my grams, 15.6 grams, what am I gonna do? Divide by my molar mass, as long as I didn't make a mistake. We're gonna go with my number here. Okay, 15.6 divided by 110.98. I get 0.1406 moles. I make an error.
There's probably 2 or something.
CaCl2, 2 of the chlorine, because calcium has a positive 2 charge. 0.1406, yep. Okay, then what am I doing? What's my volume? We get 0.28. Are you okay? I'm trying to go through this fast so you can get through them all. We're probably not going to make it, but we'll try. So 6 done, 7. Stop me if I'm going too fast though. Rather, going to 8. Alright, how many liters of this molarity solution can be prepared from 455 grams of this K2CrO4? So we're starting out the same way, right? This time it's asking about liters or whatever, so I'm going to start out with my grams, which is 45.5 grams, divided by 194.2 grams per mole. Oh, 455? Thank you. 455 grams? Oh, that's just what I said. Let's forget. 4, 5, 5. Little. Alright. Dividing those out, I should get 2.34 moles. Correct? Okay, now I'm being asked about the volume instead of molarity. Normally I have my molarity, right? Or I'm trying to find molarity, sorry, and I just divide by the volume. So, I write it based on that formula of concentration equals moles divided by volume, right? Or liters, whichever way you want to think of it. So what am I going to put where? 2 is for concentration. 2 then, good. Okay, so I should have a volume that's equal to 1.17 liters. As long as I get it. Good? 10 we did, 11 we did, we're on to 12? Oh, we missed 9? I missed 9? Alright. 9. Okay, 9 says find me volume. Well, 0.200 molarity. We have the moles, 0.001 moles. I want to find volume. Same thing that we just did.
What you should do, you should, if you don't finish the questions, you should just keep writing them down, and then after school, you can just go in.
I have so many things to do after school, it's not even funny. If I have a chance,
That's good, Joe.
Good?
Yeah.
Okay, so 10 we did, 11 we did, we're on 12. Okay, how can we prepare the such and such and such thing? Starting off with or we get to this point. X just being what is my moles. Okay, then I'm going to then take my moles and do what? Trying to find multiply by molar mass because we're trying to find mass, right?
Yeah, we're open.
Well, so far we're all guessing the right thing. Does this make sense? Because it says how can we prepare it? So when we're preparing it, I would need to know how much mass I need, and then would show me how to do that. Okay, so we're on to 13.
Yeah.
Am I going too fast here? Nope. Alright, 13 is going to be A has C1 V1 equals C2 V2. We have our 0.050 polarity, 0.005 liters to give me 0.1 liters. And my C2, solving for C2, 0.0025 N. Good?
Yep.
Okay, what mass of copper sulfate is present in this? Okay, so again, this is our concentration that we're going to start with because we just calculated it. The molarity is there. I have to convert my 10 mils to 0.010 liters. I'm going to solve for this, get 4 zeros, 25 moles. Okay, and once I have my moles, what are my next step always? Oh. Finding mass? Molar mass then? So my molar mass is going to be multiplied. 159.35 grams per mole. Which is going to equal 3.99 times 10 to the negative 3 grams. I will try my best. Wait, so I'm gonna do this and I'm gonna record so you guys have to be quiet.
No, that's huh? Oh.
Have a good night. See ya, good night.
just gotta run over and get another computer, cause I can't load that, SketchUp 7 on the, for Ben.
Oh, okay.
It's just the house, I'll be back in 5 minutes, okay?
Yeah, that's fine.